We're taking a look at Lab E today and looking at surface tension, which is a property that we see in our liquids especially, that's related to intermolecular forces, or IMFs. So although the lab experiment doesn't specifically mention intermolecular forces, we're going a little bit deeper, and these should be a part of what you write up in this experiment. So you'll see in the lab video in a few minutes here a paper clip floating on water. Try that at home. Everything in some of these labs at the beginning here is meant to try it at home. And the first thing that you're going to do, if you have a test tube, fine. If you have a small glass, you could also try to add a little bit of water to that. But if you have a full test tube or a full glass, how much more water can we add to it? And I realize that you may not have access to something that can stand in for a dropper at home. So if you don't have the equipment for this, just watch the video that's been provided and work along with that to write your observations down here. So you're gonna see the test tube. You're gonna add water to it. This picture, not so great because you don't wanna hold the test tube because then you can kind of tilt it one way or the other. But you'll see that you can put a test tube or a glass like sturdy in a rack or on the counter and then add water to it. So you wanna be watching how this goes in the video. And then you're going to describe, so these are my observations. What happens as I add water to the test tube and also to the penny. And then on number 3 here, it says use the illustration to describe why water has such a strong surface tension. Also include intermolecular forces in your explanation. So you guys know more than the middle school students that this was written for. And so you should use intermolecular forces as you describe what's happening with surface tension. And these intermolecular forces, just be aware that they are represented by these little arrows here. Sometimes you might see them in your textbook or in your class drawn as these vertical lines. These are intermolecular forces here. So how do those relate to surface tension? And then you're going to compare water and rubbing alcohol. Rubbing alcohol's formula is C3H7OH. So you're going to compare the water and the alcohol being dropped onto pennies. Again, if you don't have the droppers around, this is all done in the video for you, okay? So you can add drops of water to each of them, or water and alcohol. You may be able to count the drops, otherwise just give qualitative observations. If you can't get an exact number, just estimate here. And notice that the alcohol drops tend to be a little bit smaller than the water droplets, back to that surface tension piece. So you take your best educated guesses based on what you see here. Here is the alcohol, and here is a water molecule. I want to just point out that in these pictures, this should be a partial negative, and a partial positive, and a partial negative, and partial positives, and that's saying that this side of the molecule is kind of positive and this side of the molecule is kind of negative. So you're going to use that polarity to relate to the surface tension. And again, you might include intermolecular forces when you make that discussion. The last bit that you're going to see in this surface tension experiment is how detergent or soap affects water's surface tension. So you'll see a couple of pennies, and this is an easy one to do at home. You don't necessarily need the dropper, even maybe if you can get some water on a penny, not sure. But you'll have pennies, each with water on them, and then we're going to add soap and see what kind of impact that has on the water. So you will see in the video that each of the pennies gets touched with a toothpick and then dipped in soap and touched, and you see what happens there. In this picture here, these are the water molecules, all these little Mickey Mouse looking things, and again the arrows are just intermolecular forces. Here's my detergent or soap molecules right here. And so they have what we call polar heads and non-polar tails. This would be a polar head and then a non-polar tail. And so you can see that there's some attractions between these detergents and the water, and you're going to want to use that to describe what's happening here. All right. And then there's a question just to kind of get you thinking. Water soaks into paper towels but not wax paper. Why? What's alike? What's different there? So on this, if you have questions, make sure you start this lab early so you can bring questions to your instructor during the week. All right, so have some fun watching the surface tension and maybe even playing with it a little bit at home.